By definition, scientists don't know what to expect as they inspect the interstellar object 3I Atlas, since it's only the third object detected from beyond the solar system in human history. But the surprises just keep coming. The mysterious entity, which was first spotted hurtling towards the sun from far beyond in early July, has fascinated researchers ever since. As Science Alert points out, a quartet of powerful telescopes, NASA's Hubble, SphereX Transiting Exoplanet Survey Satellite, TESS, and James Webb Space Telescope, have now turned their powerful gazes to observe 3I Atlas. Take a moment and give us a like for this video. Thank you so much. And while there's a broad consensus among experts that the object is a comet, a small icy body that releases gases as it passes by the sun, the data tells a strikingly more nuanced story, making clear that the object is deeply strange in ways that will make it a topic of study and comparison for many years. For one, SphereX and James Webb observations have both shown that its coma, which is a large atmosphere of gas and dust that surrounds a comet's nucleus, bears a much higher proportion of carbon dioxide gas than expected. In fact, scientists found it to have the highest carbon dioxide to water ratio ever observed in a comet. TESS, which had technically already spotted the object months ahead of its July discovery that were later found in its archived observations, showed the object was already bright and active when it was 6 astronomical units from the Sun, well past the orbit of Jupiter, far more distant to be showing activity than most comets. NASA's Hubble revealed a teardrop-shaped cocoon of dust coming off of the comet's solid, icy nucleus, yet it does not feature a distinct cometary tail, according to Harvard astronomer Avi Loeb, who has colorfully suggested that the object could have been sent to us by an extraterrestrial civilization. The object's origins remain as elusive as ever. In a preprint paper, an international team of researchers posited that 3I Atlas may contain ices exposed to higher levels of radiation than solar system comets, or it could have formed close to the CO2 ice line in its parent protoplanetary disk. For now, we'll have to be patient until the findings, as well as any future observations before it screams back out of the solar system's other side, undergo further analysis and peer review. By the time the object makes its departure, it will have made relatively close flybys of Jupiter, Mars, and Venus. Loeb has proposed that NASA's Mars Reconnaissance Orbiter should have a closer look, as the object comes within less than 2 million miles of the red planet. And roughly 5 months later, NASA's Juno probe could intercept it as it approaches Jupiter. Perhaps then we could finally get a better sense of its peculiar nature. A tantalizing feature of the highest resolution image of the interstellar object 3I Atlas is the unexpected appearance of an anti-tail. This image of 3I Atlas was taken by the Hubble Space Telescope on July 21, 2025, when the object was at a heliocentric distance of 3.8 times the Earth-Sun separation, AU. The anti-tail is an extension of the glow of scattered sunlight around 3I Atlas towards the Sun, and not away from it, as typically the case for comets. This anomalous anti-tail, not a result of geometric perspective, had never been reported before for solar system comets. A new paper that I co-authored with my brilliant colleague, Eric Keto, provides an explanation for the development of an anti-tail based on a simple physical model. In short, our new model associates the glow around 3I Atlas with scattering of sunlight by ice fragments that are shed from its surface, rather than refractory dust particles as previously assumed. Most of the scattering stems from ice grains with a size comparable to the wavelength of sunlight, about half a micrometer. The ice fragments evaporate after some time, but because of the enhanced mass loss in the sun-facing side, more of the bigger fragments can reach a large distance, giving rise to an anti-tail. In other words, the anti-tail represents an extension of the snowline, or survival distance of a sublimating ice grain, in the direction of the sun. The extension of the glow is due to the difference in the sublimation mass flux in the solar and perpendicular directions caused by the change in the illumination angle of the object's surface. The stronger sublimation mass flux in the solar direction results in ice grains with larger sizes, longer sublimation lifetimes, and a snowline at a larger distance with respect to other directions. The observed surface brightness profiles as a function of illumination angle are well reproduced by our model for a constant outflow velocity and sublimating ice grains with angularly dependent survival lengths. Pause for a few seconds and support me with a subscribe. The paper models the glow as scattering by a spherical outflow of sublimating ice grains as a function of angle around 3I Atlas, whereas the sublimation mass flux off the object's surface is predominantly carbon dioxide, as observed by the Webb Telescope and the Sphere-X Space Observatory. The longest surviving grains are mostly made of water ice, which evaporates more slowly than carbon dioxide ice. From a chain of simple considerations, the new model determines the maximum ice grain size and terminal velocity as a function of the illumination angle to derive the survival length. The survival length dictates the extent of the glow of scattered sunlight around 3I Atlas as a function of illumination angle. The sublimation of ice grains, driven by the sublimation mass flux of CO2 gas from the nucleus, determines the observed curvature of the profiles and the angular anisotropy. Within a spherical outflow model, the anti-tail emerges naturally as a consequence of anisotropic illumination. The angular dependence of the characteristic length scale for the destruction is primarily due to the illumination angle of the object's surface, which affects the sublimation mass flux of CO2 gas. The mass flux determines both the terminal velocity of the ice grains and the maximum size in the grain size distribution, and therefore the characteristic survival length of the ice grains in the outflow. The plume of gas extending out to at least 35,000 kilometers around 3I Atlas is dominated by carbon dioxide, CO2, 87% by mass, with traces of carbon monoxide, CO, 9%, and water, H2O, most of the remaining 4%. Together with the path of 3I Atlas being aligned with the ecliptic plane of the planets around the Sun, at a chance probability of 0.1%, the above characteristics make 3I Atlas anomalous relative to familiar icy rocks. The development of an observable anti-tail depends on a favorable combination of composition and solar insolation that both affect the sublimation mass flux off the object's surface, as well as the destruction of ice grains by sublimation. In particular, the total scattering cross-section is dominated by volatile ice grains. The sublimation mass flux and radiation pressure should not be so large as to create a traditional cometary tail, both indicating that an anti-tail is more likely to be observed at larger heliocentric distances. This in turn requires high angular resolution observations, such as the image taken by the Hubble Space Telescope. As 3I Atlas approaches the Sun, the physical conditions and shape of the glow around it will change. That the plume of gas and ice is shaped by the solar radiation and solar wind to a teardrop shape, as observed last week by the Gemini South Telescope, is a straightforward consequence of gas dynamics and not a clue about the nature of the nucleus. The situation is akin to observing a plume of smoke carried by the wind. Without a resolved image of the source of the smoke, we cannot tell whether it originates from a burning log of wood or the exhaust of a car. The transition from red to green-blue colors of 3I Atlas, observed in recent days, might be associated with the steep rise in the production of cyanide, as reported by the Very Large Telescope on August 25, 2025. The production of both cyanide and nickel without iron, as known for industrial production of nickel alloys, was found to increase dramatically with decreasing heliocentric distance to the power of about 9. This morning, the Atlas Telescope team released data dating back to March 28, 2025, showing that the 3I Atlas was active much earlier than previously thought. The cross-section of scattered light around 3I Atlas grew inversely with heliocentric distance to the power of 3.9 when the object was farther than 3.3 times the Earth-Sun separation. Once 3I Atlas got closer, the growth was moderated to a power law index of 1.2. The Atlas team interprets this anomalous evolution as a shift from scattering of sunlight by dust lifted from a reddened surface to the production of small, optically bright, icy grains. which changed the opacity of the plume of materials shed off by 3I Atlas. The latter conclusion is consistent with our new model, except that the model argues for the dominance of ice and not refractory dust at a heliocentric distance of 3.8 AU. Altogether, 3I Atlas is different from the first interstellar object, 1I Oumuamua, which displayed no signs of gas or dust around it, but nevertheless exhibited non-gravitational acceleration. It is also different from the second interstellar object, 2I Borisov, which behaved like a familiar comet. In the coming months, we will learn much more about the nature of 3I Atlas. Evidence-based science is rewarding as long as scientists who interpret this evidence do not pretend that there is nothing new under the sun. This interstellar wanderer, older than our sun itself, isn't just a chunk of ice and rock. It's a cosmic messenger, whispering secrets from the void that could redefine our understanding of the universe. And oh, the emotions it stirs. The awe of witnessing something truly alien, the frustration of unanswered questions, the sheer excitement of piecing together its puzzle. It's what keeps me, as a comet specialist with decades chasing these celestial ghosts, utterly captivated. A visitor from another star system, hurtling through our neighborhood at 13,000 miles per hour, challenging every textbook I've ever held dear. Recent observations have only amplified the mystery, painting 3I Atlas as a rebel among comets. Just days ago, fresh images from the Very Large Telescope in Chile revealed a dramatic color shift, from a reddish hue to a vibrant green-blue glow, likely triggered by a surge in cyanide production as it nears the sun. This isn't mere cosmetics. It's a chemical frenzy, with cyanide and nickel levels spiking to the 9th power as heliocentric distance drops, a phenomenon unseen in our solar system's comets. Picture it. A comet switching on like a neon sign in the cosmic night, its plume dominated by carbon dioxide, 87% by mass, laced with carbon monoxide and scant water. This composition screams anomaly, perhaps forged in a distant protoplanetary disk near the CO2 ice line, or battered by eons of interstellar radiation that stripped away volatiles we expect in familiar icy bodies. But let's not bury the lead. 3I Atlas is growing a tail, and it's doing so in ways that defy gravity and expectation. Gemini South's latest shots show a teardrop-shaped envelope of gas and dust extending 35,000 kilometers, sculpted by solar wind into a form that's more fluid artwork than rigid science. Yet, there's no traditional tail streaming away from the sun. Instead, that peculiar anti-tail persists, an optical illusion born of larger ice grains surviving longer on the sunward side, as my colleague Eric Quito and I modeled in our recent paper. It's emotional, really, watching this object evolve in real time, knowing it could disintegrate or reveal more surprises as it barrels toward perihelion on October 29, 2025, at just 136 AU from the sun. The stakes heighten with its upcoming flybys. In October, it'll skim within 2 million miles of Mars, offering NASA's Mars Reconnaissance Orbiter and ESA's probes a golden opportunity for close-up scrutiny, perhaps detecting radio emissions or structural anomalies that hint at something unnatural. Then, Jupiter in March 2026, where Juno might intercept it for spectral analysis. Harvard's Avi Loeb, ever the provocateur, speculates on extraterrestrial origins, noting its improbable alignment with the ecliptic plane, a mere 0.2% chance, and lack of clear outgassing, despite non-gravitational wobbles. Is it a probe? A relic? My pulse quickens at the thought. We're on the cusp of history. Friends, this isn't just science. It's a call to wonder, to feel the vastness that humbles us all. Hit that like button if your spirit stirs with cosmic curiosity, and subscribe to join me in unraveling more. Together, we'll chase the stars because 3I Atlas proves the universe still holds wonders that can ignite our souls. Who knows what revelations await as it slingshots back into the interstellar abyss? Stay tuned. The best is yet to come.